Hi folks, welcome back. So this is going to be another data analysis video. So still recording a series of videos here about probability distributions. In the last video, the previous video, I started by talking about the normal distribution, the Gaussian distribution, sort of introduced what that was and the kind of parameters you need to specify that type of distribution when it's used as a model. And I also demonstrated how to use NumPy and to simulate data that follows a normal distribution. Essentially, when we looked at plotting data and then obtaining parameters for data using like a standard normal distribution. So simulating some data that followed a standard normal distribution with a mean of 0 and a standard deviation of 1. And then kind of like how to obtain statistics to check those parameters. Okay, so what I'm going to do in this video is kind of follow on from that, demonstrate how to kind of create a data frame with more than one simulated variable essentially. So what I looked at in the previous video and kind of these cells on this Jupyter notebook was how to simulate kind of one array of data, one vector of data, so to speak. So what would be the equivalent of one variable. But as I kind of said at the end of the last video, mostly when we're doing some sort of statistical analysis or investigating a research question, we want multiple variables and we're going to investigate the relationship between those variables. So when we're simulating data like this, we want to create data frames essentially that consist of multiple variables. Okay, so that's what I'm going to do here in this video is create a pandas data frame consisting of a number of variables, and then I'll also show another way to generate data that follows a normal distribution, but this time using SciPy. Okay, so what I'll do first is create a data frame using pandas. So I'm going to create a data frame with 3 variables. So just call them var1, var2, var3, variable 1, 2, and 3. And they could represent scores on some kind of scale or measure. And they're going to be essentially floating point numbers, decimals. And we can pretend we've recorded them from participants or their observations for some sort of research question. So I'm going to create a pandas data frame using the pd.dataframe method. And in order to create multiple variables and stitch them together, I'm going to pass a dictionary showing the variable labels as the keys, and then an array of random numbers that follow a normal distribution as the values for each of the keys, so the key value pairs in the dictionary. So I'm going to simulate that data in a similar way to the previous video. I'm going to use it's going to follow a normal distribution. We're going to use the np.random.normal method. So if you look at this cell here, I'm creating a data frame called df. I'm using the pd.dataframe method, and I'm passing within the parentheses, we've got these curly braces, and within that I'm passing 3 sets of key value pairs, variable 1, and then the value associated with variable 1 is going to be random simulated data with a mean of 0, a standard deviation of 1, and 500 data points or observations as such. Variable 2 is going to be the same. It's going to consist of 500 data points. So I've given variable 2 a different mean, standard deviation. Variable 3 likewise. To create this pandas data frame, we kind of want each variable to have the same number of observations, so we don't have missing data. And this third variable will give it a mean of 6 and a standard deviation of 2. So let's run that cell and ask for the head of the data, and you can see there it's created this nice pandas data frame where the column header is the variable name for each variable that we've simulated, and the values in each of the rows represents the scores for each observation on variables 1, 2, and 3, and they are floating point numbers. Okay, so this data is kind of in a nice tidy format with each variable in a column and each observation participant in a row. We can obtain descriptive statistics for each of these three variables we just simulated using the pandas describe method, and that will kind of give us some indication of. It's kind of useful to look at, I think, because it'll kind of give some indication of what the actual means and standard deviations are for these for each of these variables with 500 observations in them. So you can see for variable 1, we've got a mean of 0.034984, so it's very close to 0, and if you remember, we asked for a mean of 0 and a standard deviation of 1 for variable 1, so the standard deviation is 1.002100, so they're not exactly 0 and 1, but they're very close, and there's always going to be some sort of random noise, especially when you're kind of randomly simulating data, or even more so when you actually collect real data. But likewise for variable 2, we asked for a mean of 3, a standard deviation of 2.4. We've got a mean of 2.97, a standard deviation of 2.27. So we, very close to the values we asked for. Likewise with variable 3, mean of 6, standard deviation of 2. We've got a mean of 5.9, a mean of standard deviation of 1.98. So they closely correspond to what we asked for, the type of simulated data we asked for. So we've got data that closely approximates the distributions that we wanted when generating these three kind of variables or groups, when simulating them. What I'm going to do next is kind of generate some more data that follows a normal distribution using SciPy. So we're going to use the stats.norm.rvs random variates method from SciPy. And then what I'll do is kind of simulate for one variable, kind of two different groups, really scores on two different groups, and then we'll kind of concatenate and join them together, and then add them append those to this data frame as a fourth variable, so to speak. Okay, so what I'm doing here is I'm going to simulate some data that also follows a normal distribution, but I'm using an alternative library and method. So in this case, I'm using the SciPy norm.rvs method. So this function takes the same parameters as the previous method used, so loc, scale, and size. So loc being the mean, scale being the standard deviation, size being the number of data points. So in this first cell here, what I've done is I'm creating a variable called group 1. It's got 250 participants with a mean of 10 and a standard deviation of 2.4. So let's run that. And then likewise, this second cell here, I'm creating another group 2, using norm.rvs random variables from SciPy. This time we'll give it a different mean, so a mean of 11.5, standard deviation of 2, but also 250 observations or data points in this particular object. Okay, so we could visualize both of these objects, group 1 and group 2, that we have just simulated using the seaborn-hist plot method. And if we do that, we see that they're not perfectly normal, but they with 250 data points, they're kind of starting to look a little bit of negative skew in this one, but they're starting to approximate kind of a bell shape, so to speak. So we might want to, with these two groups of simulated data, we might want to create a normally distributed data that consists of different groups or categories, where those groups have different means and standard deviations. And what we could do is we could achieve this by concatenating or combining the two group objects we just created. So we've got one large variable. In this case, because each of those objects consisted of 250 data points, we then have one variable of 500 data points, which is not obviously by chance, because that would then match the 500 data points we have for our other variables that we simulated here. Okay, so let's do that. So all I'm doing here is I'm creating a new variable 4 val4, and I'm using np.concatenate, and then I'm passing within double parentheses here, if you notice, the group 1 object and the group 2 object. So I'm basically telling NumPy to join these two together as kind of one long array. And if that's worked correctly, if we kind of use the shape method on this, we should see that variable 4 now had the 250 observations from group 1 and the 250 observations from group 2 have been combined. We've now got 500 participants or observations. Okay, so we can also obtain a histogram for this new variable 4. And if we do that, what we see is we've got, if we combining these two distributions here, we've got a variable that's kind of still looking reasonably normally. It's starting to approximate kind of a normal shape. Okay, so variable 4 is a combination of group 1 and 2. It's slightly negatively skewed still. It's starting to approximate a normally shaped distribution, and it consists of 500 data points. So what we might want to do is we could append this to our existing pandas data frame of simulated data. Okay, if we were looking to create some sort of larger, more complex data set that we were wanting to use to practice running analyses on or to investigate. Okay, so to do that, all we need to do is kind of specify the data frame that we created above, create a new variable, we'll call it var4, variable 4, pass that as a string, and var4 is going to be the var4 object that we created just here, this combination of groups 1 and 2. And if we run this cell with the header, you can see now that this fourth variable has been appended to our data frame. So we've now got four variables, all they're numeric, they're floating point decimals, so they're kind of like continuous numeric values for each of these variables. And what we might want to do, what we do know now though, is that variable 4 consists of kind of scores for two groups that actually differ in terms of their mean and standard deviation. So what we might want to do if we run some sort of analysis is compare those two groups as part of an analysis. So as such, it'd be useful to add a column with the group labels showing whether a participant was in group 1 or group 2. So basically, to attach or append the column showing the labels for the group categories, what I'm going to use the pandas cut function. A thing to note is I've had to specify to use the data frame index df.index. Okay, and in creating the bin size, I've started from -1. So if I remember Python 0 index, if I start from 0, it would exclude the first kind of row of data for some reason. So what I'm going to do here is create a new variable called variable 5, and we're going to attach that, append that to the data frame, and then we're going to use the pandas cut method, and we're going to use df.index. The bins are going to go from sort of the first observation to the 250th, and then from the 250th to the 500th, and the labels. So basically, start point, end point, and cut point. So we're using 3 values to specify 2 bins. The first bin is going to get label group 1. The second bin is going to get the label group 2. So if we run that for the head, what you can see is we've now got a 5th variable, and it's a string variable, an object specifying which participants were in group 1. And if we look at the tail and the second 250, so the bottom end, you can see which participants were in group 2, or some of them anyway. So with a data frame like this, consisting of several variables that are normally distributed, and we've also got a normally distributed variable consisting of 2 groups, and a variable indicating which score belongs to which group, so variable 5. We've got a nice kind of simulated random data frame made of random data that's in kind of like a nice long and thin format, and we could use it to conduct different analyses. So that includes things such as the inferential tests comparing the means of our two groups on variable 4. So we could conduct like a t-test here comparing group 1 and group 2 in terms of their scores on some outcome variable. Maybe variable 4 is an outcome variable, a dependent variable. Okay, so hopefully this was useful. I'm going to make another video after this looking at kind of another example of a normal distribution, and then how we can use the PDF, the CDF, and the PPF to kind of look at to sort of examine specific values and things like that and probabilities. But what I've done in this video is I've kind of demonstrated how we can create. Often when we're kind of analysing data, we need more than one variable. So I've demonstrated how we can simulate variables using kind of like the NumPy random function or method. We can stitch them together as like a pandas data frame. We can also use the SciPy norm, the RVS method, to create variables, and we can concatenate variables with kind of different means into one variable, and then what we can do is kind of stitch all that together as a nice neat data frame, and that gives us something that we might be using maybe for educational purposes, to kind of teach people how to do analyses. But always quite useful to be able to simulate data and investigate how certain statistical tests perform on different types of data, and especially where we're confident that we know what the distribution is. Okay, so I hope that was helpful. I'm going to stop talking now, and I'll record one more video about the Gaussian normal distribution and the kind of parameters and how we can play around with those. Okay, thanks for listening.